Alright guys, now let's see how to use the functions e power x, root x, log x and a power x in chain rule. Alright, it's very important to know them. Okay, let's work on them individually. Let's take y is equal to e power x as a function. How do you differentiate this guy? Simple as that. Dy by dx would be equal to e power x itself. Alright, that's the answer. We know this formula, right? If we have to write it in a more detailed format, e power x can be written as dy by dx is written as e power x into d by dx of x. Okay, but I know that dx by dx is 1, so that goes to e power x. So this is what we actually do, but we don't write this step, not necessarily because it becomes 1 and it doesn't make any difference, right? But however, if I go with y is equal to e power any other function, let's say this time I take a bracket. So now what happens? So it goes like dy by dx goes like e power that function into differentiation of that function. This is more important. Okay, let's do a small problem with this. Let's say y is equal to e power, let's talk about tan x. Okay, so e power tan x, anything like e to the power, any function basically has to be written as differentiated as e to the power, same thing. I just write the function back again, my question back again, into the differentiation of whatever was in the head of e, that is tan x. If you can see how it works, if x comes here, x comes here, x comes here, and x comes here, right? So the 3 places you got to fill. Whatever comes here should come here and here, both, right? So if tan x is here, tan x is here, and tan x is here. That's it. So how do you get this formula? It basically from this only. So we know that is the answer, but this is what you don't write. I'm just filling this guy up. Okay, so here also e power tan x, I write e power tan x, right, into differentiation of what is in the head of e, that is tan x. See what happens. So it goes like e power tan x into differentiation of tan x is secant squared x, and that's it. Very simple. What if something else was there? Let's say it's not tan x this time. What is it this time? You can choose whatever function you want. Okay, whatever function you want. So it remains the same. The format is same. Let's take log x this time. So it goes like e power log x in a differentiation of log x, and that becomes what? E power log x into 1 by x, because differentiation of log x is 1 by x, and that's all about it. So that's how you deal problems connected to e power x and chain rule together, right? Now let's talk about the next guy there, that is root x. This is too many times used, many times used into differentiation. So let's say y is equal to root of x. Okay, so how do you differentiate this? That goes dy by dx would be 1 by 2 root of x into d by dx of x. Alright, so but I don't write this. This cancels up, that's why I don't write this. I'm doing all of them in detail so that you understand what's happening. Okay, 1 by 2 root x is what is the answer which we know. Correct, this is the answer which we know. How did this come? It came with this step and this step both. So if I say that I need to write y is equal to root of any function, okay, it's not x this time, it's any other function. Okay, that's what makes it a chain, right? There are two functions. So first thing, whenever there's a root, I just differentiate 1 by 2 root of what? Whatever is inside. If it was x, x comes here. Then I differentiate also x. So I need to differentiate who here? The bracket. So the d by dx of that particular function or the bracket. That's it. Okay, now let's go ahead. That is dy by dx, right? So dy by dx would be 1 by 2 root of that whatever function into the, okay fine, let's say we fill this up with something else. Let's say we fill this up with let's say tan x. So what happens? You get a tan x here and you get a tan x here. So what happens to the problem? 1 by 2 root of tan x, yes, into, how do you differentiate this guy? That is secant squared x. That's it. Very simple. So what if I have something else here? Let's say I have a power x. You should get all these guys will be replaced with a power x into a power x, and the differentiation of a power x is a power x log a. And you can see that even now I'm differentiating only one function, which which comes from those 23 formulas which is discussed in the starting of this chapter. If you're watching it somewhere in between, please go back. There's some different rules and different methods which I've taught in this whole complete session of video class. All right, so you got to come from starting, otherwise you're not understand what I'm talking. Good. All right, come back. If I can shift or change this function to something else, anything you want. Okay, so let's talk about this guy is secant x. So that goes like 1 by 2 root secant x in a differentiation of secant x. That's it. So that is secant x into, how do you differentiate secant x? That is secant x into tan x, and that's how it goes. All right, so whatever comes here has to come in all these places. Now, what do you understand by differentiating root? Whenever root comes, it just goes like what? Root is 1 by 2 root. That's it. All right, see, if you get a root, you need to do this. That's it. Okay, we don't have to write this. Okay, cool. This is what we have to do. You see a root, it goes like 1 by 2 root of whatever inside, into differentiate whatever is inside. Very important, used many times. All right, so let's continue with the last two guys.